What kind of integrals do we call improper? If one or both integration limits are equal to positive or negative infinity, we call such integrals improper. So here we may say that this integral is called improper, and to find its value we have to calculate such limit when t tends to infinity of integral from a to t f of x dx. We may say that such integral is equal to the square of infinite area. For example, let's calculate such integral. Here we have to calculate integral from 1 to infinity of 1 divided by x squared dx. How to calculate such integral? We may say that this integral is equal to limit when t tends to positive infinity, integral from 1 to t of 1 divided by x squared dx. And we know that 1 divided by x squared integral is equal to negative 1 divided by x. So we may substitute instead of x t, then subtract substituting unit. So this limit is equal to unit. It means that this improper integral is equal to, its result is equal to unit. The same way we may solve such integrals with negative infinity instead of a. And the case when integral is from negative infinity to positive infinity. Let's consider such a case. Here we have to calculate integral from negative infinity to positive infinity of exponential function dx. Let's divide our integral into parts from negative infinity to 0 and from 0 to positive infinity. Then consider separately both integrals. Here we have improper integral. We have to write limit when t tends to negative infinity, integral from t to 0, exponential function dx. So we know that integral of exponential function is equal to itself. That's why when we substitute 0, it's equal to unit minus exponential function with degree t. And when we calculate such limit when t tends to negative infinity, we know that here we have 0. That's why the result is unit. It means that this improper integral is convergent. The second part is from 0 to positive infinity. So here also we have to rewrite this integral as limit when t tends to infinity, to positive infinity, of integral from 0 to t of exponential function. Here also the result of such integral is equal to itself, to exponential itself. When we substitute t, which tends to positive infinity, here we see that exponential function with positive degree tends to positive infinity. That's why the result is positive infinity. It means that the second part of our improper integral is divergent. That's why we may say that the sum of convergent and divergent integrals is divergent. So we may say that if for a function y which is equal to f of x, there exists its antiderivative, capital F of x, at all integration interval from a to positive infinity, then we may say that we may calculate such integral using Newton-Leibniz formula. Antiderivative at t minus antiderivative at a. So it may be written that integral from a to infinity of f of x dx is equal to antiderivative at infinity minus antiderivative at a. In this example, we have integral from 2 to positive infinity of 1 divided by x squared minus 1. How to calculate? Here we know that we may separate this huge fraction in two parts, 1 divided by x minus 1 minus 1 divided by x plus 1. So its result is equal to 1 second or 1/2 multiplied by a natural logarithm of such expression. So when we substitute infinity and 2, the result will be natural logarithm of square root of 3.